Okay, let's look at this experiment. So this is an experiment to assess how the load, i.e. the weight on the end of a string, affects the power output of an electric motor that's pulling it up. Now, we should be able to write methods just by looking at the title of essentially the aim of what it wants us to investigate. So we should, the kind of process we go through there is we look at what the independent, dependent, and control variables are. So we want to see how changing the load, so the load is the independent variable, affects the power output. So we're looking at the power output of an electric motor, and then everything else we have to keep the same. So for instance, things like the type of motor, the voltage, other things we'll come across as well, we have to keep the same. So let's have a think about how we're going to do this. We want to work out this power, okay? And we don't have a powerometer, something that's going to measure our power output. So in that case, what I always think of is, what equations do we have that link them together? So we have power equals work done divided by time, okay? Now I can measure this using a stopwatch. So I'm beginning to get an idea of what equipment I'm going to need. The work done, we don't have a work done-ometer, but we do have an equation for it, okay, which is that our work done is equal to a force times the distance. We can measure distances using a meter rule, and this force is just the weight on the end of the string. So we can then get a little idea of how we're going to do this experiment. So we're going to have a little table or desk. We're going to have our motor on that with a little pulley hanging over the edge of the desk, and there's going to be a piece of string. We're going to hang some weights in this, so this will be our load. We time how long it takes to lift that a certain distance. Therefore, we're going to need a meter rule to measure the distance. So you should always include all the equipment you need. This is our motor. And we're going to time how long that takes, so we then need a little stopwatch, okay, to measure the time. Now, I'll demo that in the next video, but once we've got all that, we can then add some things to our control variables, because that distance that it gets lifted, we're going to want to keep that the same as well. So we're going to change the weight on the end of the string. We're going to time how long it takes to go up that string. We've got our apparatus. Let's look at the method. So it's a setup. The apparatus is shown in the diagram above or to the side. Label diagram, that can get you half the marks for an experiment. We then measure distance in 1 meter using the meter rule and put markings there. We're going to keep that the same the entire time. We put the first load that we're going to use, 50 grams, on it. We set the power supply to 5 volts. We turn it on and we raise it. And we time how long it takes to do that. We've then got our first set of readings. What we then do is we get more readings, so we can repeat an average, and we get more readings at different loads. So we change the load. We're going to increase it by 50 grams until we get up to 300 grams. And when we're saying what we change, we also say what we keep the same as well. So we change the load, but we keep the voltage the same. Same person charge of time. We keep the distance the same each time. And that's how we're going to get our readings. However, in our method, we should also include what we do with our readings. So we want to see how load affects power. So we need to calculate those things from the readings that we have taken. So we can calculate the work done using the equation W equals F times D, where the force is the mass, which we said was 50 grams, multiplied by gravity, which on Earth is 10 meters per second squared. So we can convert from mass to into a force. Distance is 1 meter, and we should convert the mass actually into kilograms as well before we put it into that equation. Once we've got the work done, we can divide that by the time using our power equation. Then we've got the two things we're interested in. We have the power and the load is what we're interested in, and we can plot a graph of power against load. Okay, so record another little video of me just showing you how that experiment would work, and then we'll go through the results that we would have gotten. Okay.